So here's another problem from 2.2, and it's another problem where we have the cross-sectional area. And this is kind of interesting because they give us an equilateral triangle, or equiangular triangle, which is the same as equilateral triangle. So the area for this that we're looking for is, I had to look this up, square root of 3 over 4 times a squared. That's the area of an equilateral triangle. So again, I would split this up into two parts. One has a constant length. That's this from 1 to 2. We have this rectangle base. And it's going to have an equilateral triangle. Right, and assuming that these were supposed to be the same lengths as the sides. So if we look at the side length, this is from here to here is 4. So it's 4. This is supposed to be 4 and 4. So our A in this case is going to be 4. So the area of the cross-sectional piece, the slice, is square root of 3 over 4 times 4 squared, which is going to be the square root of 3 over 4 times 16, which is 4 times the square root of 3. I'm going to switch back to blue because I like blue more. Okay, that's just for this part. Now we have this other portion, which is this triangle out in front, and the point to this is this cross-sectional part is varying. It's not a fixed amount. But we can come up with a formula for it, like how far is it from this horizontal line to up there to this line. And we see the rise is 2, the run is 1, so y equals 2x. Rise over run. So if I think about this, this part is 2x, and this part is 2x. So A is the whole way across. A equals 2x plus 2x, which is 4x. So my area is going to be the square root of 3 over 4 times 4x squared. Or square root of 3 over 4 times 16x squared. And that reduces to be 4 times the square root of 3x squared. Now we'll do the integration. So we're going to integrate, and that goes from 0 to 1 to get the width part of it, or the length, whatever you want to call it, the base part of it. So 0 to 1 of 4 times the square root of 3. This gives us our cross-sectional area, and we need that cross-sectional area is growing as we get out there. And so we will end up with 4 times the square root of 3x cubed over 3 from 0 to 1, which is 4 times the square root of 3 over 3 times and 1 minus 0. So it's just 4 times the square root of 3 over 3. So we end up with 4 times the square root of 3, and I'm sorry that that 3 was not well written, over 3 plus 4 times the square root of 3. We'll multiply this by 3 over 3 to get the common denominator. So it's 4 square root of 3 over 3 plus 12 square root of 3 over 3 equals 16 times the square root of 3 over 3. And that is the area. This is getting fun yet?